Okay, so let's go through this. Let's have a look at the steps we go through to complete the square. It's been a while, so let's review this. Now, somebody help me out here. Remember, when we want to complete the square, before we can start, we have to set things up. We have to get everything into what form before we can complete the square. I'll get you started. X squared. What?
Oh.
Plus.
This was that song.
Plus X.
No.
Yeah.
Plus bx
Dx and then the
Square.
equals c. Okay. All right. So it's been literally a week, and I doubt you probably did a ton of math over Thanksgiving.
No, didn't do anything.
So. All right. So what this really is saying then is we've got to get the first two terms by themselves, and the coefficient of x squared has to be 1. Right? So to get into that starting position for completing the square, we always have to start there. What are the things that have to be done to this problem?
Subtract 6.
Okay, first thing is I got to subtract 6. I've got to move the constant to the other side, right? So if we do that, then we're going to get 2x, so here's step 1, 2x squared minus 2x equals negative 6. Okay, now what? What else?
Half of b goes in squared.
Okay, but we're not quite there. Notice that the x squared has to be by itself, and it's not yet. It's being multiplied by. What am I going to do? Here? Not yet.
Divide 2.
Divide by 2. Right. So whatever the coefficient of x squared is, I should have everybody's focus up here, please. Okay, whatever the coefficient of x squared is, I've got to divide both sides of the equation by that, so I can get the x squared by itself, right? So we're going to do this. So we're going to divide, step 2 is, we're going to divide each side by 2. Okay, the right side's easy to deal with, but the left side, let's talk about that. When I divide the whole left side, meaning both terms on the left side by 2, what I'm really doing is I'm dividing each term separately. So I want to separate those fractions, right? Whether you do that on paper or in your head, I don't care. That's up to you, but you have to do it. We have to set this up so this first term is going to become 2x squared over 2, and the second term is going to be minus 2x over 2. So I'm going to split the fraction into separate denominators. It's a common denominator, so the denominators would both be 2, but I'm going to write it as 2 different fractions. Equals negative 6 over 2. So what's that going to give us? What happens in this one? What's 2x squared over 2? Go ahead. X squared. The 2's cancel, and so we get x squared. How about here? Minus x, right? The 2's cancel there. Okay. Equals negative 3. Now notice I left a space. So now we're all set to complete the square. Let's remind ourselves how that works. If we've got something like this on the left side, remember that the way this works, we're going to add something to both sides so that what we get on the left becomes a perfect square trinomial, right? Perfect square trinomial is one that's going to factor into the same factor times itself, or the same factor squared, right? So we know then that before we do anything, we can set up the left side. We've really got 2 lines in our algebra. We've got the starting, there's step 1, and there's step 2. And we're going to write out both of those steps at the same time. We're going to write out the whole template, and then we'll just fill it in piece by piece, right? So we get, that's what line 2 is going to look like, and it's just going to equal some number, right? Okay, let's take a trial run at this real quick. Let's just remind ourselves how we did this part, what it means to make a perfect square trinomial. We'll come right back to this problem. But what if we did something like this? What if I told you I'm just going to give you 2 terms, x squared minus 10x, and I want you to add just the right number to that, so it's going to factor into, so it's going to become a perfect square trinomial. What's it going to be? What's it going to be? 5 squared. It's going to be negative 5 squared, right? What is b in this case? Yeah, b is negative 10. So what we're really interested in is half of b, which is what? Negative 5 squared is 25, right? So we're gonna add 25 to these first two terms to create a perfect square trinomial. Let's factor that. Okay, if we factor that, right, we're just gonna play the number game, right? I'm gonna, if I factor this, I've gotta find numbers that multiply to 25 and add to, so what are they? -5 and -5. So look what we got. What we got was x minus 5 squared. Well, there's the -5, right? See how it worked? Okay. So now let's go back to our problem and apply that logic. So it's really easiest to just start down here, isn't it? So what is, this is, by the way, this is the hardest possible completing the square problem that you could have. If you can do this one, you can do any of them, right? So going to this line right here, we're in the form x squared plus bx equals c. What's b? -1, isn't it? Right? So we know that b is -1. So then what's b over 2? Negative. Okay, but let's make it a fraction. So -1/2, right? Everybody agree? And I get that either by dividing by 2 or multiplying by 1/2. Either way, it doesn't matter. You get the same thing. So that's important because that's what goes right there, isn't it? Right? When I build my perfect square trinomial, I know that it's going to factor into x plus 1/2 b squared. Right? So really, the first thing I do when I write out these first two lines for completing the square, the first blank that I'm going to fill in is that one. And it comes from there. Half of -1 is -1/2. Okay, what's the next one I fill in then? I've got to fill in, well, I know what C is, but ultimately, think what my purpose of this is, right? My purpose of doing this is so I can take this equation that had both x squareds and x's in it. So I was unable to isolate x, and I'm going to complete the square to rewrite it as an equation that has a single x so I can isolate it, right? I just need to know what goes over here on this side. But to know what goes over there, I have to know what I added to both sides to create the perfect square trinomial. Right? It's going to be, well, it's based on that number. The -1 gives us that number, b over 2. And whatever that one is, squared is going to give us the number that I add to both sides. So what's -1/2 squared? 1/4, isn't it? Right? Think about that. -1/2 squared. I can do this a bunch of ways. I can think of it as just squaring the top and squaring the bottom, or if you want to, just write it as -1/2 times -1/2. Negative times negative is positive, right? And then I multiply straight across. 1 times 1 is 1, and 2 times 2 is 4. But I've got to do the same thing to both sides, right? Because it's an equation. I can't just add something to one side of the equation and leave the other side hanging. I got to do the same thing to both sides. Right? And so that's important because that tells me what my number is going to be on the other side. I've got to figure out what -3 plus 1/4 is, right? That make sense? Okay? So then -3, let's do that. What's -3 plus 1/4? -3, write it as a fraction. Now, if I'm going to add up fractions, what do I have to get? Common denominator. What's it going to be?
4.
It's going to be 4, isn't it? Good. So I got to multiply the top and the bottom of this fraction by 4, right? What's that give me? -3/1 times 4/4 is -12/4 plus 1/4 is how many fourths? 11, isn't it? Because I leave the bottom the same, and I just combine the tops. -12 plus 1 is -11, right? So that's the number that goes there, right? And so really all I'm doing then is I'm just going to solve that. Let me rewrite that. That's really messy. But that's the completing the square part, isn't it? We're done with completing the square now. That's kind of a lot of work, but look what it did for us. It got us to a very simple equation to solve, right? So now we can stop completing the square and solve this equation. Right? So let's okay, so now that part's easy. The last two steps after I've completed the square are always the same. What are the two steps in order to isolate x? What do I have to do first?
Square root.
Got a square root to get rid of the square. Then what?
Add
I'm going to add a 1/2. Then I'm always either going to add or subtract some number to get the x by itself. But that's it, right? So let's go through those. If I square root both sides, that's going to cancel the square. That's good. So that gives me x minus 1/2 equals. Now let's be careful with this. What do I always have to include if I square root both sides of an
Plus or
equation?
minus.
Plus or minus. Good. So we get a plus or minus, and then I've got to just simplify that. Okay, but right away I can see one thing going on. If I have a negative inside the radical, what does that immediately turn into? An I. Good. So this is going to equal, so this equals the square root of 11/4, okay, which I can split up. Square root of 11 over square root of 4 times I, right? And square root of 11 I'm stuck with, but what's the square root of 4? 2. So then what we get on this side is just going to be plus or minus square root of 11 over 2 I. Okay, everybody agree? And then last step,
Add the 1/2.
add 1/2. So we're going to add 1/2, which I'll put in front of the plus or minus, right, to both sides. So those cancel, and then I get my answer. X equals 1/2 plus or minus square root of 11 over 2 I. So what do I put in Moodle?
1/2.
Need commas. Good. So I'll take the plus sign, I'll enter that, comma, that, right? That's it. Okay? And that's a hard one. That's hard for many reasons, but it's hard primarily when we had I's in it, sure, but the other thing that made that kind of hard is that B was not an even number, right? And so we ended up getting a fraction in there, we had to deal with some fractions. You know, if you get one like that on the test, I'll make it one that's maybe worth like half credit. So it won't be as big a deal. Okay? Make sense? All right. So moving on. This is where we left off a week ago exactly. We were talking about what happens if we create a formula for ourselves, if we make life easy for ourselves. We're going to do some work, and I'm not actually even going to do the work today. We'll come back and do that later. I don't want to break our momentum here because I want us to focus on just solving quadratic equations. But as we'll see later, if we take a quadratic equation in standard form, which is just written like this, ax squared plus bx plus c equals 0, and we do the whole job of completing the square, so we subtract c from both sides, divide both sides by a, complete the square. There's a little bit of algebra involved, but when all is said and done, what's going to happen is we're going to end up getting these answers in terms of a, b, and c. We never plugged in values for a, b, and c, so this works for any quadratic equation in standard form. If we just plug in the values of a, b, and c into this formula, right? So there's the quadratic formula. Let's try an example using this. So what if we had something like this? So we've got this equation. We want to solve this without going through the whole process of completing the square. We're just going to set it up in standard form and then plug and chug. Just plug numbers into the quadratic formula to get our answers and simplify. And that's all we have to do. Okay, so it gets a little bit easier. But the algebra comes in before we can even do the quadratic formula, we have to get to this starting point. It has to be a quadratic equation in standard form. So what are we going to do to this one?
Add 3x.
Okay, let's add 3x squared to both sides. Okay, so if we do that, that's going to give us on the left side, negative 7x squared plus 3x squared is how many x squareds? Negative 4. Good. Negative 4x squared minus 7x minus 3 equals 0. So we got it in the right form. Okay, but I'm going to add one other part to this that's really important. This would work, but the quadratic formula gets way easier to use if you make sure that a is always positive. Okay, so that adds one little step, but it's a very simple step. If we just always want to make sure that a is positive, if it starts off being negative, all I've got to do is multiply both sides by negative 1. If I multiply both sides of this equation by negative 1, what's it going to do? Yeah, it's just going to change the signs of each term, right? That's all it does is flip the signs of each term. And 0 just stays 0, right? 0 times negative 1 is still 0. So if I do that, if I multiply each of these by negative 1, what do I get back for the first term?
4x squared.
Okay, I get 4x squared plus 7x plus 3 equals 0. And then all I've got to do is just identify what are the values of a, b, and c and put them in that equation. And that's it, right? So what's my a? 4. Good. What's b?
7.
What's c?
3.
Plug them in to that, and I'm done. A little bit of simplification, and I'm done. So what's that give us? So I end up with x equals negative b. Well, what's that going to be? Negative 7 plus or minus square root b squared. What's that? What's 7 squared? 49. So there's my b squared minus 4 times a times c, right? All divided by 2a. So you remember, I got to put a line under the whole thing. A real common mistake is to only put a line under the radical, but we have to put a division bar under the whole thing. And then it's 2 times a, and a was just 4, right? So those are both answers. One of them corresponds to the plus sign, one corresponds to the minus sign. All we've got to do is just simplify that a little bit. So let's see what we get if we simplify. Let's just work on what's inside the radical here. Okay, so we get 49 minus 4 times 4 times 3. What's probably the easiest sequence to multiply those numbers in?
Wait, do you have to simplify that?
Yeah, you do. Yeah.
4 times 4.
You could. To me, that would be okay. To me, I would go 4 times 3 is 12. 12 times 4 is pretty easy. What's that? 48, right? So that's going to give us, this part right here just gives us 48. So then I've got the square root of 49 minus 48. What's that? 1. Yeah. All divided by 8. Well, what's the square root of 1? 1, right? So then I just get x equals negative 7 plus or minus 1 over 8. So we're going to get two solutions here. One of them corresponds to the plus sign. So if we take the plus sign, what's that going to give us? We're going to get, yeah, negative 7 plus 1 over 8, which is what, negative 6 over 8? Which reduces to what? Negative 3/4. So there's one answer for x. What if we take the minus sign? Then we get x equals negative 7 minus 1 over 8, which is just negative 8 over 8, which is what? Negative 1. Those are my two answers right there. Okay, no big deal, right? All we've got to do, what did we do? Not very much. All we had to do was get the original equation into standard form, and then just plug everything into the quadratic formula. So
Will you go back?
To do that though successfully, the only thing you really got to remember is, you got to remember, and I think I already showed this to you, but
Oh, no.
No.
you got to watch it again because you got to remember it. You have to remember the quadratic
It's
formula.
like my favorite video. I wasn't good writing that down.
Oh, you'll get a chance again. You will need to after this. Of course you are. Okay, so real quick.
I was still writing down the answer.
Oh, but now you don't even need to. You got to memorize now. Watch this. So what is?
You should ask all individually if you know it.
Before we can do it, we have to put the quadratic equation in standard form. What's that?
X squared
AX.
AX squared plus B squared
Plus bx.
Plus C equals 0.
Okay, and if we start there, then x equals. Come on now.
Plus or minus square root. B squared minus 4A squared.
C
Divide by
divided by 2A.
There it is, right? Okay. So that's it. If you know those two things, you can solve any quadratic equation pretty easily, right? So it does something else for us too that I just had barely started talking about. So we know that if we have a quadratic equation in standard form, you guys now know this, you got it memorized, you know what the quadratic formula is, but think about the example we just did. It was a little bit complicated because it had some fractions and things. It wouldn't be as hard to do. Well, actually, the second one we did didn't have any fractions. It worked out fine. The example we did by completing the square, we probably could have done more easily by using the quadratic formula. It was a little bit complicated because we had i's. Now, see if you can make a prediction here. What part of the quadratic formula is going to determine whether or not we have i's in our answer, whether they're have imaginary parts? Okay, yeah, it's got to be the part inside the radical because the i's come from the square root of a negative number, right? So that part that sits inside the radical, we call the discriminant. And we just give it the, a lot of times we'll just assign a capital D to it. Capital D for discriminant. It's just that part that sits under the radical. Well, about half of the last assignment is doing nothing other than just looking at or taking a quadratic equation and predicting how many real solutions it's going to have, right? So what's going to happen here? We know that if the discriminant, the part under the radical, is positive, Dalton, are we going to get any i's if it's positive? No, we're not, right? In that case, we're going to get two answers, one for the plus and one for the minus, and we're not going to get any i's, and so we would get this case, right? If the discriminant is positive, we know we're going to get two real solutions, right? What if the discriminant is negative? Am I going to get i's?
Yes.
I am. Yeah, if it's negative, then that's that case. If it's less than 0, then I know I'm going to get complex numbers. I'm going to get two of them. One for the plus and one for the minus. I'm going to get no real solutions. Instead, I'm going to get two complex solutions that have i's in them, right? Imaginary parts. What about the in-between? What if the discriminant is exactly equal to 0? What if we calculate b squared minus 4ac and it equals 0? Then think what happens to our quadratic formula. We get x equals negative b plus or minus the square root of 0, which is what? What do you think the square root of 0 is? 0. So negative b plus or minus 0 over 2a. Does it do anything to add or subtract 0 from b? No, so really all I'm getting there is just negative b over 2a. Well, how many solutions are there?
One.
Just one. Not two this time, just one. So if the discriminant is exactly equal to 0, we get one real solution. What does that look like in terms of a graph? Because part of what I want you to do is to be able to look at a graph and make a prediction about the discriminant. So what if we had something like this guy here? If we calculate the discriminant, it might be useful to multiply both sides through by negative 1. We don't like having a negative coefficient of x squared, do we? Right. So what if we change the signs by multiplying both sides by negative 1? What do we get?
2x squared
2x squared
minus x plus 5 equals 0.
So then the discriminant is just b squared minus 4ac. What's that going to give us? What's b squared?
Negative 8. Negative 8.
squared is what? 64 minus 4 times 2 times 5, right? So what's that give us then? 64 minus, well, that's going to be a number less than 64, isn't it? We don't even care what it is. I just know that 64 minus a smaller number is positive. And on some of these, I don't care what it is. It doesn't ask me. All I want to know is how many real solutions are there. Well, what's the answer? How many is it going to be? 2, right? Because the square root is we have a positive number under the square root, so I'm just going to get 1 for the plus and 1 for the minus in the quadratic formula. Well, the graph would look something like this then. Would you agree? Here's why.
I agree.
Because think about what we're finding. When we take an equation like this, right? So we've got the equation like 2x squared. Whoops. This is just, we just graphed y equals 2x squared minus 8x plus 5. If I graph that parabola, when I set it equal to 0, what am I really doing? I'm just asking the question, when does y equal 0? Right here, right? So whenever we write a quadratic equation in standard form, the graph of that, the solutions are going to be just the x-intercepts, which we call zeros. So I can look at this graph and say, well, I can see visually that this thing intersects the x-axis in 2 places. So I know it's got to have 2 real solutions, the x-intercepts or the zeros, right? What about one like this? What about that one? How many intersections does that have with the x-axis? How many x-intercepts?
1.
It's got 1. And so what do you suppose, if that's the intersection, what do you suppose the value of this discriminant would have to be? If it's got 1 real solution, it's got 1 x-intercept.
0.
It's got to be 0, doesn't it? Right? And we can show that it does. If I could divide both sides by 2, couldn't I, to make this easier? So that gives me what? X squared minus 4x plus 4 equals 0. So b squared minus 4ac would just equal 16 minus 4 times 1 times 4. What's that equal to? 16 minus 16 is 0, right?
Yeah.
Okay, so it worked. How about this one? What do you think? How many x-intercepts does it have?
0.
0. So it's got no real roots, because the real solutions, the real roots would be the places where it crosses the x-axis. So what do you think the discriminant would have to be? Positive, negative, or 0?
Positive.
No, it'd have to be negative, wouldn't it? Right? Right? Because it doesn't have any real zeros. It doesn't have any real solutions. Okay? Yep.
There was a stabbing in Ohio State. Guess what? They figured out they were based in school at Oregon University.
What?
Yeah, crazy, huh?
That's crazy. That is crazy. Okay, do that assignment. I'll give you a work day tomorrow to wrap it up, get questions answered.
Your break.
Very good. Very good. Oh, did I not?